Hi, everybody. Welcome back. Today we're going to work on inverse trig functions. So previous to this, we've been working on regular trig functions, and now we're going to do the inverse. So let's talk about first what we've done in the past. So in the past, we've had something like this, where it says sine pi over 4. And what that means is that we've been finding the trigonometric function, the trig function of a certain angle. So the angle in this case is pi over 4, and the answer has been a ratio, right? It's a fraction showing that relationship between them, right? So the sine of this angle is this fraction, the cosine of that angle is this fraction, etc. So let's just review the process for doing that since it's been a little while. So we have sine pi over 4. I remember pi over 4, this is in radians. In my head, I'm thinking, oh, this is 45 degrees, right? 45 degrees. So I'm gonna go ahead and draw that triangle over here, 45 degrees. Drop that perpendicular line right there. Since this is 45 degrees, I know that one is also 45, 45, 45, 90. It's gonna make these sides 1 square root of 2. Within this, I know that I have positive x and positive y, so I'm going to leave them both positive. Radius always positive. I remember that sine is y over r, right? Y over r. So my y in this case is 1, and my radius in this case is square root of 2. I am close to my answer, but need to rationalize. So I'm going to go ahead and multiply square root of 2 on top and bottom. So I get square root of 2 over 2 as my answer for the ratio. Okay. So in this case, they gave us the trig function and the angle, and now we had to find the ratio. For our new direction, in order to find the inverse, right, the opposite of that, we are going to they're going to give us the ratio, right, what it's equal to, and then we're going to find the angle. That's why the variable is here next to sine. So the new directions look like this. Find the value of t, right, the angle, right, this is our angle, given that t is in between 0 and 2 pi, right, so 0 is less than t is less than 2 pi. I'm noticing here 2 pi, that's in radians. That's a full circle in radians. So I'm automatically thinking, okay, my answer should be in radians because of that 2 pi. If it said 0 is less than t is less than 360 degrees, then I would know that my answer should be in degrees. So I'm thinking, okay, so it's going to be in radians. Use the coordinate plane to draw the reference triangles. Something to notice, there's an S here, reference triangles, right? There are going to be 2 triangles that we have to draw here, and I'll show you why. So they give us the ratio. We're going to find the triangle. We're going to find the triangles and then find the angle. So for this one here, it says sine t is equal to the square root of 3 over 2. I remember that sine is y over r. So I know that y is square root of 3 and r is 2. So I'm going to go ahead and draw. I know my y is positive, and I'm thinking, okay, y is positive right here. So it could be over here. My y could be square root of 3. My r could be 2. However, there is another triangle that can be drawn, which is this triangle over here. Because over here, the y can still be square root of 3, like that, right? And the r can still be 2. You might be saying, well, what about this one? Why can't I draw that one, right? And the reason is because when I put square root of 3 here on this y, that y is actually negative. I don't want negative y, right? I don't want negative y, I want positive y. So that's not possible, right? And then same thing for this one over here. This would be negative square root of 3y. I don't want my y to be negative, right? So these are my 2 possible triangles. I need to fill in the rest of my triangle here. So I have 2 square root of 3. I recognize that's, that 1, 2 square root of 3 triangle, right? My 30, 60, 90 triangle. So this is going to be 1. And for the other one, negative 1, because my x could be negative as well. So I'm thinking, okay, this is 1, 2 square root of 3. That's 30, 60, 90. Across from my smallest side is my smallest angle, 30. It's going to put 30 up here. I have my right angle, and then 60 degrees. 60 degrees in there. So I have two possible triangles here. My first angle that could be is this one here, right? Remember it's measured off of the positive x-axis, right? That right there is going to be 60 degrees, just like it's shown in the triangle, 60 degrees. That's for my orange triangle here. Okay. Then remember that I have another triangle over here, my red triangle, right? I have 60 degrees on this side. So what does that mean for this whole length here, right? So if I'm measuring off of the positive x-axis, it's going all the way over here to with this line there. That's going to be 60, and then this space here. Since this is 60 here, I know that the whole flat line, right, would be 180. And I'm taking away the 60 that's over here for this reference angle. So this green angle must be 120 degrees. So I have 120 degrees like that. Right? So we have two possible angles that it could be. It could be the angle that comes out of the orange triangle, or it could be the angle that comes out of the red triangle. Remember that my answer should be in radians. So since this is 60 degrees, I remember 60 is one of the ones to remember, pi over 3, like 180 divided by 3 is 60. And then 120 is two of them, so I'd have 2 pi over 3. These are my two answers for this question. I can check it by putting it into my calculator. Let me go ahead and pop that over here. First, I typed in the square root of 3 over 2, which is this here, to see what that value is. And then I went ahead and typed in the sine of something. So I used the degree function. Sine of 120 would be that same number, right? Same number, because I want them to be equal to each other. Same thing if I put in here 60 instead of 120, right? I get that same number, right? This is when my calculator is in degrees. If I put my calculator in radians, then that's not the same anymore because I don't want 60. I'm going to do pi over 3. And I see that same number there. If I put it here, I have 2 pi over 3. 2 pi over 3, same number there. Technically, right, I want to put it up here, that those are mathematically the same. Right, so they get the same number, therefore sine of this angle that I found is equal to this ratio. Okay, I know it's complicated. We have lots of examples. Stick around. If you are in class, we might not do all of these in class together, but we will have some more here for the video. Okay, so okay, let's try this one. We have cosine t, so the cosine of some angle is equal to -1 over 2. So remember, cosine is x over r. Remember, our r has to be positive. So we know that 2, positive 2 is our r. And we know that x is with 1, and it has to contain the negative together, right? So -1 is our x. So I'm thinking, okay, where can x be -1? It's going to be on this side over here. So we have -1 as our x. Then I'm thinking, okay, I could have this triangle to draw, or I could have this triangle to draw, right? I have, my radius is 2. So then I see 1, 2, and I know this has to be square root 3. Square root 3. I'm going to go ahead and move that -1. Kind of looking like an angle right now. We'll put -1 here, like that. All right, so I have 1, 2, square root of 3, 1, 2, square root of 3. I know that that's 30, 60, 90. So I have across from square root of 3 is going to be my 60. Same thing here. All right, remember, my angles are measured off of the positive x-axis. So I need to figure out what this is. This part here is 60. So I'm going to do 180 minus that 60 to give me 120 degrees. And then for my next angle, right? For my next angle, I'm thinking all the way from here, all the way down there. right? So I did 180 for the flat line and then an additional 60 for this part here, right? So 180 plus 60, that would be 240. 240 degrees. It's a little messy, so I'll put it here. 120 degrees and 240 degrees. Like that. I know from the last problem that 120 is 2 pi over 3, okay? And 240 is twice as many as 120, so that must be 4 pi over 3. If that feels clunky to you, you can always do like 240 times pi over 180, right? That's going to get you 240 pi over 180. Cancel your zeros. 24 and 18 can both be divided by 6. So divide by 6, you get 4 pi over, divide by 6, you get 3. 4 pi over 3, same thing. Right? So you can do it the longer way if you want. There are many ways to get there. Feel free to trust yourself. Right, so these are my two angle possibilities. All right. So first step was labeling. Let me do this. My first step was labeling them. My second step was to draw the triangles. And remember, there's going to be 2 possibilities. My third step is to find the 2 angles. I guess I'll put that over here. Third step is to find the 2 angles. And fourth step is to convert to radians. So angles and then radians. So I'd say those are my steps. Label them, draw the triangles, find the angles, and then turn it into radians. Okay. Let's try another one. So tangent t equals 1. Remember, any fraction can be over 1. Remember that tangent is y over x. Y over x. So I have positive y and positive x. Positive y and positive x would be over here. Positive y1, positive x1. And then my other option, tangent is kind of tricky, but remember, it could be technically -1 over -1, right? -1 over -1 would also equal that 1 that was here, right? So negative y and negative x. So that could be over here. Negative y, negative x, like that. So with tangent, you're going to see your triangle is going to be in your first quadrant and your third quadrant. Some teachers have them memorized. Have you memorized that? So we need to figure out what the blue angle is, and then we need to figure out what the purple angle is here. Okay. So I know this is 1 square root of 2, which means that this is a 45, 45, 90. All right, which means my first angle, that blue one that we were talking about, it's going to be 45 degrees. And then I'll call it yellow now. To go all the way around, that would be 180, and then another 45 degrees would be 225 degrees, like that. I know that this is pi over 4, right? It's a fourth of the way, so pi over 4. I can either convert to 25, or I can know that this would be pi over 4, 2 pi, 3 pi, 4 pi over 4, and then 5 pi over 4. These are my 2 angles. All right, let's try the next one. So we have cosecant t equals 2. So remember, 2 over 1, right? Going to make it a fraction to begin with. Cosecant is the flipped version of sine, right? Flipped version of sine. You can look at this letter here. So flipped version of sine. Sine is y over r. So this would be r over y, right? R over y. So first things first, our radius is going to be 2. Our y is going to be 1. So I have my y of 1 my radius of 2. 1, 2 square root of 3 would be my other one. And then my y has to stay positive here. So I know I could have another fraction over here, or another graph over here. 1, 2 square root of 3, that's a negative on that side. So 1, 2 square root of 3, that is 30, 60, 90. 1 is across from 30 degrees, the shortest side, shortest angle. And that means that this is also 30 degrees here. I know this angle is going to be 30 degrees. And this angle here is 180, the full 180 minus this 30 here. So that'd be 150 degrees. 30 is pi over 6. And then 150 is 5 times pi over 6, 5 of these. So it would be 5 pi over 6. These are our angles there. So cosecant, very similar. We just make sure to flip it over here and then find our 2 triangles. Secant is the opposite of cosine. Cosine is x over r. So this would be r over x. Okay, this one looks tricky, but it's not actually tricky. Remember how on this problem here, we had to do the square root of 2 so that it wasn't on the bottom anymore and it ended up on the top, right? So notice this down here. Since it's on the top here, and I see 3 on the bottom here, I'm thinking like it's kind of, this is kind of weird. I don't know any triangles that are like 2 square root of 3. However, if I think about like, okay, this actually was on the bottom, then I would have 2 over square root of 3. Like that. It was actually on the bottom. So what happened was they took this, square root of 3, that became this right here. And then square root of 3 times square root of 3 became that 3 right there. Right? So we don't, we prefer that it was just in its like simpler form. And so we're going to put it like this. So r is 2 and x is square root of 3. Remember, there's a negative. Which of these could be negative? The x is the only one that could be negative, so the negative must go here. So r is 2, x is negative square root of 3. So over here, that's where our x is negative square root of 3. Our r is 2. This is 1, 2 square root of 3. Same thing here. 1, 2 square root of 3. 30, 60, 90. I know 1 is across from 30 degrees. So this is going to be 30 here and 30 there. So when I draw my 2 angles, my first angle's here. The 180 minus that 30 there would be 150 degrees. And then over here, we have the full 180 plus another, oops. Okay, go away. Sorry. Dun, dun, dun. There we go. So we have the full 180 and then another 30. And that's going to give us 210. Like that. 210. This one's a little trickier with our radians. I know that 30 is what was left here. So that's pi over 6. So that it was almost the full pi, but minus the pi over 6. This is 5 pi over 6. If that feels tricky, you can still use the 150 times pi over 180 and then simplify from there. And then 210, I know that the full one would be 6 pi over 6, and then we added another pi over 6. So this is 7 pi over 6, like that. This is our answer for that one. Okay. All right, we have 3 more. If you got it, if you don't have to take notes on all of them. All right, cotangent is the opposite of tangent, right? Opposite of tangent. Tangent is y over x. So this would be x over y, right? X over y, remember it's over 1. So when we have x over y, remember that we could have tangent and cotangent. Remember, it's going to have one positive, positive, one negative, positive, negative. So this could be negative 3 pi over 1. Negative, I don't know where the pi is coming from. Just kidding. Okay, there's two options here. The first option is that the negative is on top. The second option is that the negative is on bottom. So we could have x is negative pi square root of 3 and y is 1, or we could have x is positive square root of 3 and y is negative 1. So let's graph the first one here. Negative square root of 3 would be on my y over here, negative square root of 3, and then that's with a positive 1, so be over here, like that. The other version is x is positive square root of 3, and y is negative 1 over here. So with tangent and cotangent, they're going to be like opposites of each other. Opposites. Okay. So I'm thinking this is 1 and square root of 3. I'm going to have 2 as my radius. That makes this 30 degrees and 30 degrees. So this would be the 180 minus the 30 would be 150. And then this angle over here, this one here, is going to be all the way around except for that 30 there, right? So it's going to be 330 degrees. 330. So 150, as we remember, is 5 pi over 6, right, from the last two problems. And then 330, that's like, well, it's 11 pi over 6. One way that you could just do it is just 330 over, or pi over 360, like that. And then you could say, okay, 33 pi over 360, cancel this. Oh, what am I doing? Wow, stop me, rewind. I was like, that's not working. Pi over 180, 330 pi over 180, cancels there. And then you can simplify both of those by 3. So you get 11 pi over 6. And that's where that one comes from. It becomes easier and easier to just memorize them as you're working through it. Okay. Whew. All right, let's do tangent. 10 equals, or tangent of t equals 0. Remember, over 1. Tangent is y over x. I could have 1. I could have 0 over 1, or I could have 0 over negative 1. Those could both create 0. They both create this 0 number here. So y could be 0 and x could be positive 1. So we could have this, or y could be 0 and x could be negative 1. Okay, remember, it's not really making a triangle here. It's already there. So I'm already thinking, okay, for this first one, it would be 0 degrees, right? For this first one right here. And then for the other one, we'd have 180 degrees to get to the other side, this one here, right? So we have 180, which would be 0 radians or pi radians, right? So remember, with tangent, right, both x and y, they could be negative, right? So it could be a positive 1 or a negative 1. We're still going to get 0, no matter what. Cool. All right, last one. Here we go. Sine t over 1 over 1. Sine is y over r. So my y is negative 1. Y is negative 1. Draw this here. 1 and my radius is 1, just like that. Let me think. So I'm thinking here, It's not possible. I don't know any triangles that have a radius of 1 and an angle of y of 1. Think about that, what that would look like, right? Right? That's not going to be possible because I need my y to, in order to create a triangle, my y has to be shorter than the radius. The radius has to be the longest side. So the only way that I can do this is if I have -1 as my y, right? And my radius is also 1, would be this line here, 1 for my radius and -1 for my y, something like that. So and you might be saying like, okay, but where's the second one, right? The only other place it could be is here, but that's r is 1, but the y here would be also +1. This has a negative here. So the only place that it could be is where that purple one is, the purple one is. So we're going all the way from the initial ray to the terminal ray, and that is 270 degrees, right? 270. Number of ways you could do this. 90 is pi over 2, right? So this would be 3 of those. 90, 90, 90 would be 3 pi over 2 radians. Right. That is my answer there. Wow, hard ones. Y'all are doing amazing hard things. Good job. Don't forget, these are your steps. Label, draw the triangles, find the angles, find the radians. All right, you got this, my friends. I will talk to you soon.